Hello everyone, today's lesson is about to find the domain of radical functions algebraically without graphing. So I want you to start by thinking how can we find the domain of these two functions if we graph them using Desmos. So here's Desmos graphing application. So if I just type this function square root x minus 2 and I look at my graph, I can see that it is just one piece of the graph, continuous graph, but it has a start, and this start is this point. As you can see, starting from 2 all the way to the right means to positive infinity. And remember that domain is what is describing the x value. So here the domain is when x is greater than or equal to. This is inequality notation. If I want to write it as interval notation, it's going to become starting from 2 all the way to positive infinity, close bracket from the left at 2, because of the equal sign and open bracket at positive infinity. If we try the second function, so cube root, so I need to find the nth root function. So it is here. So I can put here cube root as it is mentioned here, and down it is x to the power of 2 minus 2. So in this function, where it is graphed in green, so I can see that the graph is everywhere to the left and everywhere to the right, and there's no any disconnections or holes or any so it's one piece. So this means that it is continuous everywhere, and therefore this function has a domain of all real numbers. And how can I write all real numbers in other way? So either using the R, capital R, with the little I next to it, representing the set of all real numbers, or I can use interval notation from negative infinity until positive infinity. I want you to try square root x squared minus 2. So if we just come here and do square root x squared, let's make it minus 4, for example. So minus 4, okay. And what you can see two separate pieces. So one piece going all the way to the left to negative infinity, starting from negative 2, and the other piece starting from positive 2 going all the way to to the right, to positive infinity. So here the domain is two pieces or two intervals. So starting from negative infinity all the way up to negative 2, and I can equal negative 2, so I would put close bracket, union, in addition to positive 2 all the way to positive infinity, which is the right piece of the graph. So now we need to learn how can I find the domain of a radical function without graphing. So if you look at this example, so what can you notice between the difference between all three functions? You can tell me that this has nothing written here, which means 2. Also, this has nothing written here, which means 2, and this is 3. So we call these two functions are even roots. So it could be square root, and for square root we don't write anything. It could be a 4th root or a 6th root. So even roots, and this is an odd root. So cube root or 5th root or 7th root and so on. So the even root has a rule and the odd root has a rule for its domain. So I will start with the odd roots because it's very simple. The odd roots domain is all real numbers. So the domain is equal to R, the set of all real numbers, or negative infinity to positive infinity. So any odd root, I can have positive or negative under the root. That's no problem at all. So as long as it is odd root. Now if it's even root, square root or 4th root or 6th root, whatever under the square root, it has to be greater than or equal to 0. So t minus 5 is greater than or equal to 0. This is an inequality, a linear inequality power 1. I can solve it simply as same as I solve a linear equation, so move it to the other side. So t is greater than or equal to 5. This is inequality notation. If I want to write it as interval notation, so greater than, so going to positive infinity, so 5 comma positive infinity, closed bracket at 5 side, open bracket at infinity. When it comes to a square root or an even root, and I have a quadratic expression under the root, then I need to be careful in finding the domain algebraically without a graph. First of all, we agree that for anything under the even root, it has to be greater than or equal to 0. But now this is called quadratic inequality. Quadratic inequality. So if I want to find the values of x that makes this quadratic inequality true, I need first to find the zeros of the quadratic equation. So x squared minus 1 equals 0. This is a very simple quadratic equation. It can be solved manually, shift 1 to the other side. So it will be x squared equals 1. Take square root both sides of the equation. You get x equals positive and negative 1. And this is something important to pay attention for. When I do square root both sides of the equation, I have to consider always positive and negative. It can be solved by factoring. X minus 1 times x plus 1 equals 0, it will give me the same answer, x equals 1 or x equals negative 1. Or you can use your calculator Casio model FX991 ES Plus and use mode 5.3. We're gonna use mode 5.3 in future lessons and teach you how to use it. For the meantime, I have these zeros, positive and negative 1. I can draw a number line here, negative infinity far left, positive infinity far right, place the negative 1 and the positive 1. I have an equal sign in the inequality, so I will put a closed circle, which means it is equal. Now I have this, my number line is divided into 3 intervals. The first interval from negative infinity all the way to negative 1, so this is the first interval. And the second interval is from negative 1 to positive 1, and the third interval is from positive 1 to positive infinity. Now I need to test these 3 intervals. If I choose here any number, maybe negative 2 or negative 3 or anything between negative 1 and 1, the easiest is 0. It could be negative 1.5, sorry, negative 0.5 or positive 0.5. And in the third interval, I have what? Positive 2 or 4 or whatever. So these 3 values are called testing values. I chose them, and I'm going to test them in the inequality x squared minus 1 greater than or equals 0. So if I substitute the negative 2 to the power of 2 minus 1, I get 3 greater than 0. This is what I'm looking for. So this interval is part of my solution, or it's part of my domain. If I substitute the second value, which is 0 squared minus 1, remember we are substituting in this inequality to check. I get negative 1, this is less than 0, and this is not what I'm looking for. I'm looking for greater than 0. And lastly is 2 squared minus 1, I will get again 3 greater than 0, so I'm done. So my domain is this interval and this interval, so I'm going to write domain equals 2, negative infinity, comma negative 1, union 1, comma positive infinity. And this is my final answer. So now you need to practice. So if you pause the video for and try to solve these 4 questions, then you can check your answers afterwards. Okay, I'm gonna solve now. You should have already paused and tried on your own. So here, this part 4 plus square root. So this part by itself is called a constant or a constant function. So it has no restrictions in the domain. So the restrictions comes from the square root. So I need to focus on my square root and take, since this is linear under the square root, so I will take x plus 6 greater than or equal 0, solve x greater than or equal negative 6, moving this 6 to the other side. So in interval notation, so negative 6 comma positive infinity because it's growing or increasing, close bracket because of the equal sign here, I have equal sign, and open bracket always from the infinity, positive or negative infinity. And this is the domain. Similarly here, this constant or this coefficient, it will not affect the domain of a radical function. I just need to take whatever under the radical, because this is linear and it's an even root. So it's restricted domain, greater than or equal 0, move to 1 to the other side. So x greater than or equal negative 1. So in interval notation, it is negative 1, comma positive infinity, closed here, open here. For this one, I'm going to start by taking x squared minus 4 equals 0. I will get x equals positive negative 2, and draw my number line, negative infinity, positive infinity, place negative 2, closed circle, because I have equal sign, positive 2, also closed circle. Take testing values, negative 3, 0, positive 3. Substitute in the inequality, x squared minus 4 should be greater than or equal 0. So negative 3 squared minus 4 will give me positive 5, and this is greater than 0, so here this interval is part of the domain. 0 squared minus 4 is equal to negative 4 less than 0, not part of the domain. And the last thing, square of 3, 9 minus 4 is also positive 5 greater than 0. So my domain here is from the first interval and the last interval, which is negative infinity until negative 2, union, here this has to be closed because we said we have an equal sign, and also this has to be closed bracket and open with infinity. Same thing here, x squared plus 5x minus 6. This is a quadratic inequality under an even root. So if I set this equal to 0, this is a quadratic trinomial that can be solved by factoring or using the calculator mode 5.3 if you are familiar to it. So since this is a negative 6, I need to have 1 plus and 1 minus, x plus x minus. What times what gives 6 factors of 6 that add up to positive 5. So I will have positive 6 and negative 1. Right? If I add 6 and negative 1 gives me positive 5, and if I multiply, I will get negative 6. Sorry, this has to be 0, and eventually I will have x equal negative 6 and x equals positive 1. These are my zeros, and on the number line, I will place the negative 6 with a closed circle, and the positive 1 with a closed circle, and negative infinity, positive infinity, and choose testing values here, negative 7. Here I can choose 0 as well, and here I can choose 2 and substitute in the quadratic inequality, x squared plus 5x minus 6 greater than or equal 0. Then substitute negative 7 plus 5 times negative 7 minus 6. I can use Desmos to help me calculate. If you have your physical calculator, that would be easier for you. So plus 5 times negative 7 minus 6, and the answer is positive 8 greater than 0. So correct. If I substitute the 0, I will get minus 6, and this is less than 0, no. And finally for 2, I just change this to 2, come here, change this to positive 2, I will get also an 8, which is positive, and this is what I'm looking for. So my domain is going to be the first interval, which is starting from negative infinity and at negative 6. The second interval, starting from positive 1 till positive infinity. So negative infinity comma negative 6. Again here, don't forget that at negative 6 and 1 has to be close bracket because we have equal sign. And this is the domain for this function. Now it's time for you to check your answers and then do more practice for the next 2 slides. And for the last slide, this is critical thinking question that you need to think of and write who's correct in their claim and why they are correct or why they are wrong. Good luck.